Okay. Okay. Looks like I'm back. That was strange. I don't know what happened. I had to fully like log out and then relog back into Twitch and everything. Weird. Alright, well, kind of lost some momentum there. But what we need to do is we need to debug what is wrong with my level editor. So it looks like I broke something recently. In a way that's making it so that the level names, the names of the elements in the level are not getting saved out properly, which is not good. So let's test this real quick. We're going to hop into the level editor here. Okay, let's add in a bar. Let's add in a trapeze. Let's add in a moving path bar. And let's add in a mat. Okay, so like this. This is save test. Save it. Okay, so that was saved. Now if we go to here, we should be able to find that level. Maybe not. There we go. Okay. So here's the level we just saved. This looks fine. Asset names are all correct. Interesting. Okay. So does it have something to do with if you load a level and then edit it? Level data load level. Let's open up our save test level, which came through okay. Now let's add, I don't know, yeah, parallel bars or something. Level data save. Okay, go look at it. Okay, so that seems to be working okay. So why do I have why isn't this okay, edit references, reset, regenerate project files. Okay, let's just go open any random script here. See if this loads properly. Okay, so now if we say like first trapeze.level, why is this file have weird asset names like this in it? Because if we go look at like, yeah, let's look at this. We want to search for this. Okay, interestingly, this. Okay, now there's a handful of levels that are busted. Look at this. One, two, three, four. There's a lot of them. Not a ton. But these levels are all messed up. So what does that mean? Does that mean at some point something was broken in the editor? That seems a little concerning. And do they all have the same? No, it's like a whole handful of object types. Like line wall, landing mat, bamboo, okay. Basic bar, yeah, so it's not like there's a specific prop that's broken. If we look at something like this one, are there still some that are right and some that are wrong? Let's look. So that one's right. Looks like the rest of these... No, see, like the chalk is fine. Like, how did I save this in a way where sometimes it said this, sometimes it said that? The level serializer is the one who can save a level. And it does it in this function. It goes and gets all the placeable objects in the level. Loops through and says if they're to be serialized. And we call this serialized common object data, which is where this is going to be happening. That asks the object what is it at its asset name. Okay. The asset name only gets set in like one spot. Right here in load prop. And it just sets it directly to whatever this is. Okay. And we get the prefab from that. Okay. Now this is going to be happening in the editor when you add an object. And when you load a level. And in this one spot here where we add the confetti canyon manually. Okay. So this Alright, it gets all the prop asset names. Okay. This is using the prefab reference. So what's the scenario where this could get set wrong? How would it be? This whole thing, assets slash blah 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 slash blah blah blah. Now if we go here and look at this, because we now have this thing called prop what is it called? Prop list. And here are all the props, right? And our prop finder now is pretty simple. This goes through, finds all the pieces. Let's do this. Just do this. Right, this is just a list of placeable objects, which these are all asset references to prefabs, right? Here they all are. And then this guy, if when you ask him to get those, it returns the dot name, which is these things here. Bamboo, normal, but this is what the level files are expecting. Okay, so that part seems fine. And then when you ask for one by name, we do the same, we compare against the same thing. That seems fine. And then when we say load one, we use the same call, find this, and then when we do that, we set prop.assetName to be this. So I must have had some moment in time where I had this wrong and I was saving a handful of levels, I guess. Quite concerning. Now I'm gonna have to fix these levels. Which is gonna suck. Let me think. I guess I could use find and replace, but that's a little scary. Like here, for example, like this needs to just be, well, okay, yeah, so I should grab this whole thing, and I should do replace in files. Replace this. No. Yeah, find this and replace with this. It's gonna do it in go. Okay. This one. What is line wall? I think it's just gonna be this. Okay, go. What else we got? Landing mat, basic. That one is just, yeah. It's capital landing mat underscore basic. Go. Okay. What else we got? Okay. Basic bar. Replace in files. Replace this with basic bar. I think that's correct. Yeah. Go. Okay. What else we got? Really? Why are we slide along? Okay. So this one. Trapeze medium. Okay. That one is, I think it's just trapeze underscore medium, right? It is. Okay. Go. free bar. Which I believe yep. Made it like that, okay. Okay, this should be almost all of them. Okay, track mover. This is a big one. Replace. And then we just have this one bar catch U. Which, am I really even using this? I don't know. How did I make that one? Is that even in here anymore? I don't think so. Yeah, so we should actually just get rid of this level. Okay. This is a little concerning. Let's test if these levels will load now. Alright, so our save test still loads fine. Something like first trapeze, which was busted before, now loads. Just to test something, let's go like this, and let's like change this level in some way, like remove the chalk, re-add the chalk. Like that, go like this, and save the level. Okay, and let's like go click away from Unity, click back so it notices the file change, and then go first trapeze.level. Looks okay. Alright. Okay, that was strange. Now, what we were trying to do is, let's exit out here. Let's grab our, oh, that looked overly bright. Let's double check that we wanted not this hairstyle. Save. Okay, load that player, go in here, go to this level. Okay, and what we want to try is, now that we're live in the game, we want to go to our avatar here, here, and scroll into this hierarchy that you can't really see behind my head, but it's thrilling. I'm just clicking on different junk here. And we're going to go find our dynamic bones. There they are. And we're going to add a sway root bone to each one. Boom, boom. So now these each have that. Let's see. Okay, so now we've got some stretchy hair. It looks pretty weird. Yeah. Okay, let's try tweaking these settings a little bit, but this is kind of what I was worried about. So elasticity we want to be low, I think. How much can it pull away during movement, and then limit how much something can stretch. 1.0 equals no stretch. Okay. Inertia. How much inertia makes it more bouncy. Alright. What does this look like now? It looks quite weird. This is what I was worried about. This motion in this game is pretty, you know, is going to be pretty taxing on like whatever kind of little physics sim we do here. Okay. What if there's like no inertia? What does that do? Yeah, it's kind of strange, isn't it? Like it falls kind of due to gravity there, but this way doesn't. It just sort of lags around. That's really all it does. So not in love with that. I think there was another option in here too that was like, yeah, okay. So kind of as I expected, I think I'm going to need to actually try making my own little physical sim for the hair. Yeah. All right. Well, good news is, okay. Bad news is I had this very strange thing where some levels were saved in a way that was not good. I couldn't reproduce it easily, so that's good. Hopefully it just means that I had a moment in time there when I was transitioning over to the new system and I saved some levels and didn't realize that they were getting set wrong. So we'll have to keep an eye on that and make sure the levels don't break again. But we did work out that we can add bones to the hair in Blender, rig it, bring it in, and get our avatar system to keep those bones around. So now the next step is to add a little bit of simulation onto those bones. And then hook that up for all the different hairstyles that need it. Which is not trivial, but hopefully worth it. Yeah. Okay. Well, this was this was kind of a fun-filled day today, where we struggled with Blender for a while there, had a couple Unity crashes, stream crashed once, but hey, you know, we're getting it working. Hey G Rare, how's it going? Thanks for dropping by. Today was a little weird. I was streaming for a little while there, and then somehow the stream dropped, and I had to like restart my computer and make a bunch of changes to get it back up. So I don't know what happened there. And I think I'm sort of finishing up for tonight because the next task is not short. Basically, I gotta make a little hair physics helper. I'm sure there's solutions out there I could be using, but this is the kind of code I enjoy writing. So I think that's what I'm going to work on next. I'm going to, let's see, the next time I'll be working on this game is tomorrow morning. So I will pick up from there and start working on this. And I'm going to make, I could kind of prep a little bit here, where we could say, let's make a new scene. And what we're going to want is to create a mock, like, little transform hierarchy here. So this is going to be something like dynamic hair root. This will be this root bone that we have. Okay. And then, you know what, before I do this, I really should, let me save this scene real quick. Okay. Okay. I should go back real quick and look at these bones and confirm the orientation stuff. So let's go look at this again. Okay, with this loaded, if I go look at the avatar, which is right here, let's go look at one of these. So these bones are, so the main axis is in the negative x direction. Okay. Just double check that. So if I look at this one, yeah, once again, the bone is kind of looking in the opposite direction of that red line, so that's negative x. And we're going to kind of call it up is z. Not that that really matters as much. Okay. So what we're going to do here is we're going to have our little test scene. And the way this is going to work is this is going to act like the root. And then we'll have a thing here called like chain 1 or whatever. And as a test, we're going to say this one is like this. Just at some kind of arbitrary 3D rotation. Okay. And then that one's going to have a child called chain 2, which will be some offset and then some rotation. Okay. And we'll do one more to test. Chain 3, the child of this, it's offset in the negative z, and it's got some rotation. Oh, Fukijama, thank you very much for the follow. Thanks for dropping by this late night stream here. I'm potentially sort of wrapping up for tonight, getting prepped for some work I'm going to start tomorrow. Okay, so this is going to be like our little link of bones. And let's do this. Let's add a visible cylinder to each one of these. That should be rotated like this. And should be just made small. So wait, this one's going to be a child of chain 1. Yeah. Do it like this. So this is just the visual. And how far off is this? Negative 2.95. So we're going to want the size of this to be 2.95 divided by 2, I think. And then we want the offset to be this divided by 2. I think if I got that right, yeah, this should now go from here to here. Cool. And then we will make a copy of this, plop it onto this one, set the position and the rotation to be 90 on there, and chain 3 is negative 2.64 units down, so that's what this is going to be, divided by 2. divided by 2. And this is going to be that divided by -2 to cancel out the signs. Okay. Right? And then chain 3, let's just give it... It's a Pika program. Hello. Thanks for joining the stream. It's hard to tell from what you're seeing on the screen right now, but I'm working on a physics-based acrobatics game, and the thing I'm making right now is I'm planning on trying to add a little bit of physical simulation to the hair of the avatars, so that as they're flipping and doing all the stuff you do in the game, the hair isn't just locked, to the head. It reacts to what's happening. And I spent most of the stream today. Yeah, it's sort of a ragdoll game. It's like a powered ragdoll. I can actually show you the game in just a second. Let me just set this to these values, and this needs to be negative. I'm setting up a little test here, imagining that these are the different bones in a little chunk of hair that I want to then add some simulation to. So this would be like how they're modeled in the model, and then which is like the pose they're going to want to try and get back to, but they should have some bounce and spring to them. So I'm kind of setting this up here so that I can write some code to try and add some simulation to these nodes, and then test it here before I make sure it's working in a few different layouts and stuff. Because here right now I should be able to do things like this, where I could just like bend these and say, okay, well, what if the starting condition was, this or whatever, and make sure my code works. So that's the plan. Is I'm going to probably tomorrow actually start writing this code, but I wanted to get it set up. Let's go look at the game real quick though, since had a few people drop by. So the game is physics-based gymnastics game. That's why it's called Pro Gymnast. And so let's load up a level. Let's see. Here's a good one. So you can see I have the gymnast here, and basically on the controller, the left thumbstick is your shoulders, and I can kind of like, if I push down on the stick, then the arms try to go down. If I press up, they go up. I press forward, they go forward. Press back, they go back. And then the right stick is the legs. You can also use the triggers here to pull in the legs or pull in the arms. And so you can use that to build up swing, build up momentum, and make your way through the level. So here I want to release and catch onto these parallel bars and kind of repeat this process here, like this, to work my way across the level and then land on this mat. In this case, that's the end of this level, is making it to the mat. And then you see you earn some medals for completing the level. I could get another medal if I had completed the level quickly, another medal if I had beaten a high score, and another medal if I had found the special chalk collectible. And you can see there's a cool little replay there. I can actually go in here and view that replay and scrub through it, and even do things like click an input and an out point. Like, let's see, let's get to the spot where I transition here. So like in point here, boom, out point there, and hit export. And then this gets exported out to a video file on my computer, so you can post that to social media or wherever you want to, whatever you want to do with it. Game comes with a level editor, so this is how I actually make the levels in the game. Go in here, you can just add and remove objects and stuff. So you can change things. You could go like this and start it up and notice that now I just fall and land on the mat. Undo that. You know, these are all the levels I'm working on. If we go like this and exit out, you can see kind of like the layout of the game. So you come in here, you can make multiple profiles to give you characters. You can just choose from presets, or you can go in here and do a whole bunch of stuff. You can change their hair. You know, you can change the hair color. You can change a million sliders about their face or their body, and then their clothing from a few different options. You know, different tops and bottoms, shoes, no shoes, grips, no grips, which is a, you know, that's the only super gymnastics-y aspect here of this. And then you take your character in here, and ooh, I busted it. Look at that. I wonder if that'll fix itself. Nope. So you have these different locations you can go to. That really is blurry. That's not your eyes. And each location has a handful of levels. Each level you can earn a bunch of medals from, and earning medals is how you unlock new locations. And eventually you get to go to from California to Tokyo. I think if I click on this character, I can show you some examples. Here's like a tons of levels. They get kind of ridiculous. Yeah, that's the basic idea. So I'm fairly far along. I'm trying to sort of go through the tasks of finishing up the game now. And one of them was that, see how the ponytail here on the character is just totally rigid and it's not reacting to what's happening at all. I wanted to add a little bit of a physics simulation to things like those ponytails. So today I made good progress on that. Whoa! Where I worked out how I can add extra bones depending on the hairstyle and get that data to come through all the way to this live avatar. And then was about to start actually coding up the sort of simulation for the hair when I found a scary bug with a couple levels that weren't loading properly and went on a tangent to fix that. And now that that looks like it's resolved, tomorrow I will pick up where I left off and I will try to get some physics on the hair. Oh, really? I made it all the way there and then hit my head on the last bar. Ouch. Okay, I'm going to go like this. I'm going to swing around this way. We're going to do the underside release. Here we go. There it is. Grab it. Got some confetti. Beat the level. Yeah, so the game's pretty far along. I'm sort of working through my final tasks, which at this point are making sure all the I could have had the audio on this whole time. Making sure the audio is in good shape, finalizing the levels, and some final polishing tasks like the one I'm working on right now, which is adding some physics to the hair. I had tested a couple scripts that I had that I could use to do some physics on the hair, but they weren't working really great. So I'm going to try making my own, which is where this is going to lead. And so I think the way this is going to work is I'm going to end up with a new I'm going to end up with a script. Where am I going to put this? I guess on the Gymnast. Sure. So this is going to be do a script per chain. So this is going to be dynamic hair chain. And this, we could just kind of start laying the groundwork for this a little bit, maybe. So I've already kind of planned out what I think I need here. So this, we're going to assume that this script is attached to the root bone. So then we're going to have a public class that's called a chain node, I guess. And this thing's going to need, it probably could be a struct, but leave it as a class, whatever. So vector3, this is going to be the root position. Then we're going to need a quaternion, which is also public, which is the root rotation. Okay. And then we need a transform, which is I don't know what we'll call this. We'll call this the node transform. Okay. Then we need the let's think about this. So is this going to be, we're going to have like the offset says, where am I? So this says from my parent, where do I, by default, what's my offset and then my rotation. Yeah. So, and then this is going to be, what do we call this? We'll call this the endpoint, I guess. So end point world position. And then we're also going to have a endpoint world velocity. We're going to have a endpoint distance. And then we have some spring values. So I'm going to try doing it with my handy dandy spring function. So this is going to be spring frequency and spring damping. And then a reference to the next node. Something like this. Okay. And then this script is going to have just a reference to the chain. Okay. Oh, we had another thing here we needed, which is public float max angle. So we're going to have a constraint so that the pieces can only sway up to some maximum angle. Okay. So then basically what we would do is on start, we would need to generate the chain data. And actually I bet we can do this on awake. And it might be smarter to do that. So this is going to assume, and then I guess yeah. Actually, it's not going to do it on awake, is it? For that to work, we also need to know, let's just write this kind of gross to get started. So this would be the first node ref, or even the name, something like that. Public string first node name, something like this. So then what we would do is we would be like transform first node equals transform.find first node name. Transform.find the right one? I think so. Okay, and if first node equals null, we will say dynamic pair chain could not find first node called first node name. And then we would just return. Okay, but let's assume we found it. So then what we would do is we would say build chain, and this is going to take in the current transform, and then the one we're actually applying it to. And that would be, oh, and we also want, we're going to do this. We're going to say chain equals new chain node. And so it would be like for this transform, this node, and here is the chain that you're going to fill in. Okay. This be private void build chain. It takes in the transform parent and then the transform node, and then it takes in the chain node data. Okay. What this should do is it's just going to set node data dot root position is equal to the node's local position, and the node data dot root rotation is the node's local rotation. Okay, and then what else do we have? The actual reference to the transform, so node data dot node transform equals node, and then everything's a node. Okay, endpoint world position. So now for the rest of this stuff, we need a child to exist. So now what we need to do is be like child t equals node dot get child 0. And I guess what we have to do here is go if node dot child count is greater than 0. Which really we don't, yeah. Kind of like if we made it in here, we don't want to do anything else. We want to end. Okay, so if we make it this far, there must be one. So we'll use the first one because we're just going to assume that someone authored this nicely with just single bone chains. So now that we know the child transform, we can say that the node data dot this dot what is it? Well, the node data dot endpoint world position is going to start at just the child t's position, and the node data dot velocity is going to start at 0, and the endpoint distance is going to be, let's just do this in world space, so child t dot position minus node dot position dot magnitude. Okay, and then somebody needs to set max angle. Let's just set that to a default value, 45 degrees. What else do we got? And then we need a frequency damping. Yeah, so these, we'll just set something to get started. And then this is going to have to be improved later. Let's just set it to kind of a slow frequency. And let's just give it the tiniest bit of bounce. Okay, and then what we do, this node does have a child, so we call, so this should, we should do it like this. Okay. I think we go like this, actually. I think we want this to be here. Chain.node data equals new chain node, right? And then here we would say node data dot next node equals build the chain with ourselves as the parent now and child t as the next one. And that means this needs to return null. And then here we would return node data. And this is not void anymore. This returns a chain node. Okay. Now, if I mark this as system serializable, then we could do something where we just like public, or not public, but void fixed update. So this is to do simulate, and then void like late update probably. No, I don't know. I don't know about that. Void update. And real quick, let's just do a debug thing. So we'll go chain node parent equals chain. And then we can be like while parent does not equal null, chain node child equals parent dot next node. Okay. And let's just do debug dot draw a line starting with parent dot let's see, actually yeah, and then we'll say transform parent t starts with the actual transform of this object, and so we're going to say parent t dot transform point parent dot, let's see, we want to go from parent t position to parent t dot transform point parent dot root position. Okay, and then we would say parent equals parent dot next node. And let's just see if we're getting somewhere. Okay, so this would have a dynamic hair chain, and the first node needs to be chain 1. So if we run this, okay, we run it, we get a blue line. That's good. Does it go to the other objects? Let's look. So if we grab these, and we toggle it, no. All we're getting is the first one. So chain. Yeah, so I need to see if this... I don't think the inspector can show like a list that keeps linking down. So let's see here. Let's just do this. Run this. Go here. And let's debug. Okay, so what do we got here? Chain. Why can't I look at this? There we go. Chain. Next node is null. Okay, so actually what we want to do is we want to walk through this. Chain calls build chain. It creates a node, sets its next node to the next one, which would set its next node to the next one, etc., and then return back, right? Maybe I'm doing something dumb there. So let's walk through this. Okay, go in. So this node's child count is 2. That makes sense. And this is chain 1, which is what we expect. So then we work out this stuff. Wait a minute. Why does chain 1 have 2 children? Oh, right. Because I have my stupid visibility junk. Right. So that's why it's not working. Because it goes into this. So these have to be in the other order if I want to leave these in here for now. So it has to be like this, where this is actually at the top of the list. And then this is actually at the top of the list. Like that. And we're going to get one extra one probably, which is a little screwed up. I wonder, is there a way I can... I don't think so. Suppose I could find a way to debug draw this. Maybe that's a good idea. Let's do that. Let's get rid of these visibility things. Oh, whoops. Let's get rid of these visibility things. Now let's run it. And okay, we've got some kind of screwed up chain here. Okay, let's look at this again. That might be something wrong with this though. Oh yeah, hang on. So we're saying what's the transform and then what's the, let's call this node. So this should be node dot that. And then we want to say parent t is node dot node transform. Sorry, and this is while node is non-null. And then node becomes node dot next node. Okay. Okay. Now we got 1, 2 links. This one to this one. We're not getting the third one. Right, we're not getting that last one. And that's because this is like right. I may have my data structure a little funky here. Oh no, that's right. It should. Let's see. Let's walk through this. Okay. So we go in here. We're going from dynamic hair root to chain 1. Okay, chain 1 has one child. So we can definitely generate this information. This should be chain 2, which it is. Okay. And then, oh, whoops. Then I skipped over everything. Darn it. Let's try that again. Come on. Oh, Molly Pointer 12? Molly Pointer 12, that's how I'm thinking you say that. Thanks for the follow. Thank you for stopping by the riveting stream here of walking through this code. Okay, so now we're good here. Let's run this. Go like this. I think what's happening is go in here. Doot 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 doot. So by this time we're up to chain 2. Yeah, okay, that's why. I think. So we go through here. We go into this one. This still works because that's going to be chain 3. And then we go in here and we're like, nope, because chain 3 doesn't have any kids. And then we work our way out of here and we end up with a chain. It starts at, right, starts at chain 1. And then connects to one that starts at chain 2. Right, which really is, we should only have 2 links in this system. Because we should have the one going from here to here. And then the one going from here to here. Really, it's just that I'm drawing this a little weird when I draw it here. Like if we just do this and we say draw from the node transform position and then node transform point like that. Now we should see 2 blue links going from 1 to 2 and from 2 to 3. Sort of. Interesting. 2 to 3 looks okay. So we got some debugging to do here. The length is weird. This one is way off. So what's the deal there? We're drawing from Right, because, okay, 'cause this is off. This is saying right. Local position, local rotation are saying oh, right. We still need to know we need to know the like axis the axis what do we call that? Endpoint distance and then bone main axis or whatever. Which for now we know is negative x. Would be that. So that would mean that actually what we're supposed to do here is we want to transform the node dot bone main axis times node dot endpoint distance, I think. There we go. Okay. So these would be the lines that say, here's the rest position of this thing. And then later we can hopefully do some simulation that tries to pull the live positions back towards these positions. In a way that's kind of like stable and simple, but hopefully it looks cool. Alright, so that's an unassuming but good little start here of kind of getting some of this data structure set up. So in theory then tomorrow I can just try writing in some sort of simulation here. And then we can go test it on the actual avatar. We got a bunch of stuff here we need to work out. We need to work out how we're going to actually set these values per node. Yeah, these are the main ones. What's its max angle and how springy is it? What's the frequency and the damping? Assuming that that spring code works out correctly. Otherwise, we might have to use different math. And something like this, the bone main axis, is that something we would just, actually that's probably something we would just have as a global thing, like per chain. It doesn't need to change per node in the chain, so maybe we could actually get rid of that and make that a property of the whole script. So then the one spot I'm using that, which is right here, we just replace that like this. Okay. But we are going to need oops. We are going to need here yeah, ways to set things like angle limits and spring strengths kind of on a per node basis, because I'm assuming we're going to want to change those values over the course of the chain. Right, so this would be the character moving around, and then now we got to add in some kind of simulation. And so here we have two I have 2 points in this case. I should make this chain longer as a test probably, and I should get some debug drawing in here so I can see these bones kind of like visualized. Alright, that's a good stopping point for tonight. So tomorrow, I'm in California, 9 a.m. I'll be back for an hour or so tomorrow to work on this, and then on this time slot, the evening, I'm going to be doing this on Tuesdays and Thursdays. So, yeah. So tomorrow morning I'll have a short stream, and then on Saturday I'll have a short stream, and then on Monday morning short stream. Tuesday night another 2 hours or so like today was. Cool. Alright, I'm about to sign off, although we have looks like a couple people watching right now. Maybe we should see if there's somebody to raid. Let's see who's on right now. We could raid Adam. I don't know if he's just finishing up, but might as well, right? Let's see. Where is this? Here. Okay. Stream manager. Let's raid a channel. This one. So if anybody wants to come along, let's go do a quick raid. Say hello to a fellow live coder, and then I'll see everyone tomorrow.